Welcome to the Starrag Booth here at IMTS 2022. Many of you probably know Starrag for some massive machines, some of the biggest on the planet. Started around the mid-1800s. Can you imagine the longevity of a company and the technology that must go into over a century, nearly 2 centuries of education? Imagine that. And I'm with my friend Elena today, and we're going to talk a little bit more about Starrag as a whole, give you a great overview before moving into some of the beautiful technology all over this booth. So Elena, how are we doing today?
Good, we're really good. Thank you so much. And thank you for being here and visiting us.
Absolutely, and if anyone's watching that has questions for Elena, please send them in. Along this entire journey of 60 minutes, please send them in. We love answering your questions and being interactive. So with that being said, let's talk Starrag. Mid-1800s, beautiful technology. We know of Boomo tech. We look at SIP, we look at Heckert. I mean, how many lines are there here, right? From small to big.
Yeah, we have many great machines. So if you see this part, for some customers, that seems to be already pretty big. And then you look at a landing gear like this, and for some customers, that's a small part. So Starrag offers basically for anyone everything, from very small parts to really big parts, small machines to gigantic machines. You have to build buildings to even fit those machines in there.
That is absolutely right. And when I look at what's on your booth right now, I know the technology fairly well, and they're so neat because, and we're going to talk about this more, ladies and gentlemen who are watching, so stay tuned for that. But we're talking multi-axis machines where you put a raw piece in and you can put the finished part right into a box. Anything from broaching and deburring and tapping, it's all in one machine. How beautiful is that, right?
It is. But some people are hesitant to approach us for whatever reason, so I encourage everyone to visit our booth and don't hesitate to ask us any questions. We do have an amazing team here, all from Europe, from the US, from Mexico. They can answer all your questions, whatever question you have. So come and see us and talk to us about your part of your business, your future. We want to push your productivity in the future. So that's our motto for that event. So yeah.
Have you ever had the great opportunity, because I have, and I absolutely love it, when you go into a building and you see that Starrag machine, one of your bigger models over there, and it looks like the length of a runway getting ready to go into the ground in these facilities, and all the work that the engineers are doing to get those done. Have you seen that in person?
Well, I basically led that project too with one of our customers, how they built the building where you thought, this is insane, that building is as big as your entire rest of your company. And then you pour that foundation, that's just the most gigantic swimming pool you would think you've ever seen. And then you pour the foundation and how this all is being set up until a machine is in there and then can create actually a part, like a huge part in one setup. It's crazy, it's amazing.
It really is crazy and amazing, or even together in the same sentence, crazy amazing.
Yeah, crazy amazing.
So before we send this over to Paul to talk about Boomo tech, is there anything you'd like to share in German to your German friends out there that might be watching right now?
Oh wow. Also wenn irgendjemand Deutsches da ist, dann solltet ihr alle zu unserem Stand kommen. Wir haben Cookies, wir haben Popcorn, wir haben ganz viele Deutsche auch da, die immer helfen können, die auch Deutsch-Englisch sprechen. Alle vorbeikommen.
Very well said, well done. And with that being said, now let's send it over to Paul and Boomo tech.
Great introduction, Tony. As always, now I'm looking at the Boomo Tech 191 Neo. I'm going to ask this gentleman to tell us who he is and what he does at Starrag, and then we're going to get into the detail about what this machine does. Would you like to introduce yourself?
Yes, I'm Ervid, so I'm the application engineer for Boomo Tech covering the US.
Okay, and what's your day-to-day duties? What do you get up to?
Yeah, I'm doing a good day at IMTS, you know, it's always an intense day, but very exciting.
But in your day-to-day role, are you developing applications, creating turnkey projects? Is that really what your role consists of?
Yes, exactly, yeah. So I will give the training, do some time studies for new projects, for customers, a lot of different things for sure.
And you've been heavily involved in this application, which we're going to look at, which is incredible actually. This machine is mind-blowing. If you've got any questions or comments that you want to raise during the presentation of this machine, please do, because I won't be able to cover everything. There really is a lot to see. So Hervé, what I'll do is I'll move this way. Perhaps you could just, if you stay to this side, if you just explain what the Boomo Tech 191 machine is before we talk about the new Neo side.
Yeah, sure. So the Boomo S191 is basically a platform where we are using a bar feeder. So the bar is fed, and then we have a sub spindle to grab the parts, and we can machine the back side of it. So the goal is to have a part complete in one cycle.
Okay, now what's really interesting about this, and you'll see this on the camera now, and I'm going to point it out as well actually. Down the bottom you'll see that the second spindle is in a vertical position, and in a minute it will move and it will become in a horizontal position. And I spoke to Hervé earlier, and I was just curious as to what the benefit of having that vertical spindle at the bottom is. So Hervé, perhaps you could reiterate your answer to our audience. What's good about it?
Yeah, so imagine if we have the sub spindle which is facing the main spindle, the B-axis will have to go to the other way. So we will be limited into the travel, or we'll have a much bigger machine. And we all know the real estate is very important.
Okay, now there was a couple of points I raised, and as well it'd be interesting if the viewers have got some comments on this and questions as to where is the advantage other than space to having a vertical spindle like that. I was a little bit concerned about swarf getting caught up in it when it's positioned like that. What's your answer to that?
Yeah, sure. So we do have, maybe you can see on the video, but we have some nozzle blowing those chips away with coolant. So it's going to keep the platform very clean out of chips.
Now, running this part here that we're going to look at, in fact, let's look at it in your hand at the moment, if we bring the camera down to your hand. What actually is it, and why have you selected to run this as a demonstration?
Yeah, so this is a spinal implant. So we all know that the medical, the implants market is very growing. And this is a good part for us because there is a lot of different angles on the part. The surface finish has to be very good. And also the part is made in one cycle. So this is a very attractive solution for a customer making implants. Okay,
for the medical industry. Now tell us about the actual material, because it's quite tricky to machine, isn't it? It's not the easiest.
So this is PIC material. So this is a plastic that is biocompatible for the industry.
I say tricky to machine, but just not very nice to machine, is it?
Yeah, exactly. So the challenge will be the burrs. So it's quite easy to machine, but the burrs, it's really the challenge to have a burr-free on this part.
Okay, what is the cycle time, out of curiosity? How long does it take to make this?
This one is about 10 minutes cycle time. It's burr-free, so it's really ready, basically, to be cleaned.
Okay. What are the things you have to be conscious of when you're machining this material? What are the things you have to introduce onto the machine to be able to machine this material successfully? So is there anything extra you need to put onto the machine? Because what I'm thinking is you don't want the surplus material, the waste, the chips getting into the back of the machine, for example. You need to make sure that the machine's going to last the test of time, don't you? So, how do you address that?
Yeah, sure. So this is not really a concern for us because what we can do on the machine is grinding. So with grinding, you will have very small dust going anywhere. So our machine is very sealed, so equipped, for grinding. So we have customer just grinding, doing only grinding material.
Okay, so if you can do that, you can handle this.
Exactly. So it will be no problem, yeah.
Okay, now let's just have a look at the machine before we get the spindle moving, or the bottom spindle moving. Tell us about what we've got here.
Yeah, so we have a tool changer with 60 tools. We can go up to 90 tools, so this is plenty of tools. You can have sister tool as well, backup tools, and we have HSK A40. We can have turning tool as well as milling tool.
Okay, and that's what I want to get into next, actually. Looking at how long will it be now, Hervé, if you come here until the bottom spindle's actually going to move into its next position? How long is that going to be?
So this is very quick. So, for example, the sub spindle from vertical to horizontal, it will take about maybe 3 seconds. So it's very quick.
But just out of curiosity, in this cycle, how long is it until we're going to be able to see that bottom spindle move?
Oh yeah. So it will be very quick now. I think within like a couple of minutes it will go to the other position.
Okay, and what about the turning on this end? So you can turn too, is that what we're saying?
Yes, exactly. We have turning capability as well. Yeah.
Right. And what's new with the Neo then? What's changed?
Yes, so the Neo is very refreshed version. So we have better performance, so we have faster acceleration because we use the newest generation of linear drives from Fanuc, for example, as well as the tool changer is quicker by about 1.5 seconds.
Okay, and you've obviously got this new interface, like you say, this new 31i control. So you're talking about reducing that non-cut time as well, aren't we? This machine is all about cycle time reduction, productivity gains, but also extreme accuracy.
Yes, exactly. So as maybe people doesn't know, we come from the watch industry, so we are used to make very tiny parts, very high accuracy parts.
Okay. Will this, can you just tell me, Herbert, is this going to move in a minute, or are we going to have to wait a bit longer or maybe come back to it?
Yeah, I can move it now if you want. Just do like a manipulation.
Yeah, if you could, because I think it's important. I think it's important to see, because sometimes when you're looking at machines like this, it's hard to actually identify how the actual axes are all moving. But I just think it's such an important part of this machine to be able to see that bottom spindle moving into a horizontal position. It just illustrates the flexibility that the machine offers. I mean, I can think of all kinds of parts. In fact, while Herbert is doing that, if we just look in this cabinet here, you'll see there's parts, there's gun barrel parts. Again, it shows the versatility of the machine. Or if we come back, we've got it. Here we go. Excuse me there, but there you go. You can see the spindle now is in a horizontal position. So you've got the two differing planes. This means it's almost like a twin spindle turning center now, isn't it, really?
Yeah, exactly. Yeah. So at this point, we are transferring the parts. So both spindles are synchronized together, and the part is transferred to the sub spindle.
So with the two spindles and the milling head, and also the fact that that bottom spindle moves, really just shows that you've got the absolute, there it goes, total flexibility, an incredible piece of technology. But it's not the only machine that's on show here. We've also got Tony, who's over by the Starrag, so I'm going to hand you over to him, who's talking to Matt. Don't forget, if you've got any questions, any comments on this machine or anything else you see, get them onto the social channel that you're watching on now, and we'll answer them live here at IMTS. And it's now over to you, Tony.
All right, so now we get to talk Starrag with my buddy Matt. And I want to just say, guess who's Matt? Matt again. Matt is back. With that being said, also do not forget to send your comments in if you have questions for Matt, Paul, any of the guys over there. We have a lot of technology, and sometimes it can be overwhelming when we go 1, 2, 7, 8. How many axes are we talking about here, Matt?
So this is a 7-axis machine. You have you've got a main turning spindle, you've got a sub spindle, and then the sub spindle has can travel forward and backwards, as well as rotate so that it's vertical, allowing you more clearance for part accessibility. Then you also have auxiliary axes, which I wouldn't necessarily consider as a part of like the number of axes of the machine, but it allows you to do things like loading a parts changer and moving it out so that you can load up the spindle chuck and process parts start to finish without any downtime.
So when I look at this machine, 7-axis machine, for me, coming from a 3-axis world before I was overwhelmed trying to step into 5-axis in my machining days, how easy is this for someone to learn? I don't want it to be overly daunting, because I know, and you know as well, and I'm going to let you emphasize this point, is when I put a piece of raw material into this machine, it's going to come out so I can put it right into a box. No secondary operations, no need for any of that kind of stuff, which saves a ton of time, because we also know the world is trying to get into less operations, right? If we can reduce operations altogether, then we're really saving time and money. I know I've asked you several questions at this point about how daunting it could be, how easy it is to learn, how important automation might be, and how easy it is to be a part of this whole system. And I don't want to overwhelm you, so let's just first start with the system itself. For those out there watching right now going, man, I only work on 3-axis, or, oh man, I got a 5-axis, how cool would that be to learn? Let's talk about how the easy or daunting it is to learn.
Absolutely. So as far as, increasing the number of axes on a machine, I would say it maybe feels daunting at a certain point, but really, Starrag is willing to work with you guys, provide training, and increase everybody's comfortableness as far as operating the equipment, because ultimately at the end of the day we want you guys to be successful, and the only way to do that is if you're not comfortable, we need to bring you guys up to speed.
So your job is to get me comfortable with the machine. My job is to get you comfortable with the live stream. Is that how this is working?
Yes, that is exactly how this is working.
So now that we're talking about it, let's talk about the fact that now that we've talked about how daunting and actually easy it is in your support, let's talk about now it really is from raw material to box, isn't it? How does that actually happen?
Yes, so there's two general strategies that I would implement, right? Now, if you're starting from raw stock, probably what I would recommend is incorporating a bar feeder and then incorporating a conveyor type system. Now, something that's very common in the aerospace field, being an LX, is starting from a forged stock material, because you need to be able to have that grain structure in order to maintain the material performance that the engines are designed for, right? In that sort of an instance, you don't have the ability to utilize a bar feeder. You need that forged stock. Therefore, I would recommend incorporating a palletizer system where you can load the forged stock from the palletizer into the chuck using a spindle gripper, no need for robot arms. Process the part, one shot, come back with the spindle gripper, load it back into the palletizer, on to the next part. You're ready to go.
And as a machinist, and I think I know this answer as well, but I want you to say it instead of me because the audience hears me talk way too much already. How important is the reduction of operations? If this normally is going to take, you talked about automation already, but let's talk about reduction of operations. This normally takes 3 machines, 4 machines, 2 machines. When we're talking about taking apart, moving it to the next one, moving it to the next one, how important do you think is putting it all into one machine?
It's critical. It's absolutely critical. I mean, especially when you have very complex shapes with no real datum surfaces, flat datum surfaces that you can go off of. Being able to machine the entire part in one operation, you're now relying on the Swiss precision of the machine to be able to form your features. Every time you unclamp a part, reclamp a part, you're immediately implementing a risk as far as, all right, well, now my datums don't necessarily stack up to these other features.
And you said it better than me, but that's a concept that I would have tried to convey to the audience as well. So now that we're talking about that importance, what are we actually making here inside this machine? I know we were talking about peak over there, but this is more aerospace oriented, isn't it?
Correct. So this is a stainless steel alloy. This would be a compressor blade, more forward stage, and yeah, it's made from a raw stock forging to a finished blade all in one go.
That is absolutely amazing. So we have some comments coming in from the audience, and I'm going to read this to you as well because hopefully you know the answer to this. Some are more difficult than others. Sometimes people just tell us we're awesome, and we love that. But the question coming to you is, I'm upgrading my first 3-axis machine. Am I better off buying a 7-axis machine over a 5? Will the 7 do the same and more axis as a 5-axis? And this is from James on YouTube. James, thank you so much for asking that question. Matt, what do you think?
So one thing that I would say is that the more axes that you have, the more that you can do. Now, one thing that I may, as far as just general feedback is concerned, is you want to look at the part, look at what you are capable of processing to, and you might not necessarily need a 7-axis, but depending on what that part is, a 7-axis machine may lend significantly more capability to you than just a standard 5-axis machine.
That makes sense to me, and if I was going to help answer that question just a little bit, yeah, I'm with you. The more axis, oftentimes, we don't know what's coming to us, right? Yeah. And maybe the other 2 axis help us do the whatever it might be, that extra component. Maybe it's the deburring, maybe it's the finishing, maybe it's, you know, some of the other parts that aren't typically done inside of one machine. And that goes back to our conversation about reducing overall operation. So maybe we have a part that only requires 3-axis. We'll pop it in there and it'll come out beautiful. Or a 5-axis, we'll pop it in, it'll come out beautiful. But then instead of having that one 7-axis part that comes through, now we have the answer to it same way, right?
Correct. I mean, what I would say is that you want to select the correct tool for the correct job, right? And as far as airfoil milling, single blade, LX is the correct tool for the correct job.
So I want to talk a little bit about software, if that's okay with you. The interface that's here going on with this Starrag LX021. And when we talk about it, I kind of want everyone to understand how easy is this to learn? You know, we see some interfaces everywhere we look, and we're looking at this one here, and I see Siemens. How do you feel about Siemens? If the people out there that are watching this right now, if they know Siemens, they know Siemens, right? But if they know another one, is this pretty easy as well?
Absolutely. So before coming to Starrag, actually, I had never worked on a Siemens control, and I fell in love. I mean, Siemens is great. It's very intuitive, especially, you know, if you are familiar with computers, it operates off of a window-based system, so it's very consistent with what you might see when just opening up a laptop. So I would highly recommend it. It's very powerful and it's very intuitive, and you know, I feel lucky to be working with such great software.
So last thing I ask you before we throw this over to our buddies in Spanish, actually, I believe, we're throwing over to Fur, is we've talked about aerospace, and we're standing in front of a machine that's obviously a good footprint because we're all fighting for real estate. But can we briefly go over the massive ones that you guys have as well, that are some of the Heckert machines that are going into the aerospace world that really change the game of how production is being done? Instead of putting puzzle pieces together, we're making it all in one piece and all the other counterparts that go along with it. Let's talk about, I mean, because we can't put it on this booth, we can hardly put it in this building, so it's only always on video for the most part, or flying a drone around. Let's just talk about the growth and expansion of Starrag itself, if you don't mind.
Absolutely. So as far as the aerospace applications are concerned, I would say that you've got your Heckerts, you've got your STCs, you've got your LXs, NBs, and then EchoSpeeds. Now, I do have a preferential to the EchoSpeeds because they're just such cool machines. They really are. I mean, they're good for machining wing spars, so, you know, massive. I think we're talking about 10 meters, and that's for our small EchoSpeed machine, and that's the part size. That's the part, you know, length that you can use. And then our STCs, very similar, very large, and extremely powerful machines.
If I may share a story with you and the audience as well, you may recognize this name, Omni Aerospace.
Yeah.
And they have 2 of those EchoSpeed machines that you're talking about, which were absolutely ginormous, if that's even a word. And that's your baby model, yeah, and the ones that are small. Yeah. And he had an 8-pallet change that were the size of cars moving parts around. And this is where you might be able to correct me, but I believe, if I remember correctly, it was a 150 horsepower spindle just plowing through aluminum, and I believe it was right around there, and I even want to say around 40,000 RPM at 150 horsepower. That is magnificent, and they have 2 lined up with each other, and they have more coming in, right?
Yeah, so 150 horsepower, 30,000 RPM spindle, not quite
so close.
40, not quite 40. And yeah, so, you know, the base machine configuration is a 2-pallet system, but we also work with you know, our cell configurator, so you can have as many pallets as you want, really coming in, going out, loading up the parts outside the machine. That spindle will keep working, keep making chips for you.
Well, Matt, you nailed this interview, my friend. Let's go ahead and send this over for a really cool announcement about Querétaro, Mexico, with our friend, my sister from another Mr. Fernanda.
Hola, hola. As Starrag is having great news for the Mexican market, I'm going to interview in español to Carlos Castro. So, Carlos, sabemos que Starrag tiene ya máquinas en funcionamiento en México, pero cuéntanos cuál es el plan para este 2022 y 2023 de Starrag en México.
Claro, gracias por preguntar. Sí, Starrag, como su objetivo es soportar al cliente a largo plazo, nosotros vamos a abrir una oficina ya en la ciudad de Querétaro. Vamos a contar con un técnico en los próximos meses. Y para el 2023 vamos a contar con soporte de aplicaciones también para darle el soporte que necesita el cliente.
Excelente, entonces, por decir, si ahorita ya quieren adquirir sus productos en México, ya pueden contactarse contigo para que les muestres los productos que tienen disponibles y todo.
Así es, ya pueden contactarnos directamente en la ciudad de Querétaro. Como todos saben, Starrag se especializa mucho en la industria aeroespacial. Tenemos soluciones para cualquier tipo de aplicación de la industria aeroespacial, energía y transporte. También podemos hacer productos médicos de titanio y de cualquier tipo de material.
Y también en la máquina donde hacen productos médicos también pueden hacer ¿cómo se me fue? Partes para relojes y de joyería fina, ¿no?
Así es. La máquina Boomo es capaz de hacer microprecisión, es decir, relojería, implantes médicos, cualquier tipo de aplicación que requiera alta precisión.
Sí, sabemos que Starrag es conocido por su precisión y la calidad que brindan en todos los procesos, ¿no?
Así es, y para eso tenemos también el soporte de Starrag USA, a donde contamos con partes, servicio y soporte de aplicaciones.
Oye, también me enteré recientemente que dan muy buena capacitación. Si el cliente tiene algún problema, pueden contactarse con ustedes y por videollamada o Zoom los van guiando a través de todo el proceso para ayudarlos a solucionar todos los problemas que tienen.
Es correcto, nosotros tenemos asistencia remota y eso es de gran ayuda al cliente para que su máquina siempre se mantenga en marcha.
Sí, es algo por lo que Starrag se ha consolidado, de que no solo venden un producto, sino que ustedes brindan un servicio y soluciones al cliente.
Exactamente, Starrag no vende solo máquinas, sino vende soluciones. Y la solución es la máquina, la herramienta y la ingeniería. Esa es la solución que Starrag ofrece al público.
Oye, y volviendo un poquito más a lo que hablabas al principio de que van mucho a lo que es el sector aeroespacial. Veo que aquí tenemos varias piezas que van para este sector. ¿Me puedes contar un poquito? Porque sé que ustedes manejan materiales que no cualquier máquina puede manejar y la precisión que les dan y el detalle, el acabado que tienen. Que les cuentes a nuestra audiencia cómo pueden ellos tener este tipo de acabados.
Claro, una de las características especiales de Starrag es que casi todas las piezas que hacemos las hacemos en un solo setup, es decir, pueden ustedes tener piezas terminadas sin necesidad de hacer segundas operaciones. La calidad, como les digo, es el resultado de la máquina, la herramienta y el soporte, la ingeniería en este caso.
Oye, ¿y qué materiales manejan las máquinas? Bueno, ¿qué materiales pueden trabajar las máquinas que ustedes manejan?
Claro. Una especialidad de Starrag son los metales duros, como el titanio o el acero inoxidable de forja.
¿Cuál es la calidad que dan las máquinas de Starrag en estos metales? Como no cualquiera los puede manejar. ¿Qué precisión nos dan la maquinaria?
Bueno, como Boomo puede dar microprecisión, es decir, 1 o 2 micras. Las máquinas Starrag, por ejemplo, de la pieza que está aquí, puede dar 6, 10 micras de precisión, que no cualquiera lo da.
En efecto, no cualquiera puede dar tanta precisión y trabajar con materiales tan difíciles de trabajar. Así que es una gran solución para el mercado mexicano que ya lleguen para allá, para que puedan tener la opción a tener sus productos, saber cómo trabajan y a ofrecer productos de calidad en México, ¿no?
Es correcto, la industria aeroespacial en México está creciendo de manera acelerada y es necesario que también haya proveedores de alta calidad para hacerle frente a las necesidades que vienen.
Excelente, Carlos. ¿Algo más que te gustaría decirle a todo nuestro público en México y en Latinoamérica sobre Starrag antes de que pasemos con mi compañero Tony?
Bueno, Starrag ya está en México para darles los mejores productos disponibles para el mecanizado de metales.
Excelente, muchas gracias, Carlos. So, MTD friends, we're coming back to Tony in just a second. Thank you, Carlos, and thank you all.
Welcome back to this side of the room in the Starrag booth, and I'm with my buddy Murph. Yes, John Murphy, founder, CEO, and co-creator of some really cool software that I'd like for you guys to learn more about. The shortened term of that is called TAMS, but we're going to learn more about that right now with John. John, thank you so much for joining the show.
It's good to see you again, Tony. Thank you.
Always a pleasure. So TAMS, A, what does it stand for? B, let's talk about it.
Yeah. TAMS is True Analytics Manufacturing Solutions. So we provide smart manufacturing solutions for primarily complex manufacturing environments. So, if you're defense, aerospace, power generation, and you're looking to connect equipment, that's definitely what we do. Complete system integration is our thing. So if you want to connect tool management systems to your IoT platform, we're the perfect solution to that.
Well, last time you and I talked, and I love this software because you took me deeper and deeper, and then I got lost because you're just so much smarter than me, but it was so intricate and detailed. I first thought of it as machine monitoring of some sort. ERPs are thrown out there, but you actually call it something different than that. You have your own language and style because this is unique to some of the other stuff that's out there. Can we talk about that?
Yeah, I mean, we do machine monitoring, but we consider the product process monitoring because for us, it's about the tools in the process. That's what matters in complex environments. So if you want to improve your process, our product's the perfect solution for that. So we could see tool performance in a specific program on a specific machine and rack and stack based on potential improvement, and then we could get really granular, see lines of G-code versus machine behavior, and our product was developed in an advanced manufacturing environment for advanced manufacturers. So we do high-level metrics, but we're primarily a solution for engineers, machinists, programmers, people that want to solve problems on the shop floor. We have high-level management, dashboards, but it's really about the machinists, the programmers, engineers.
So let's get excited about this a little bit, shall we? Sometimes we think of machine monitoring and we go, well, I know I need it, but how do I do it? Who do I work with? And sometimes we just want to see chips fly on a machine, right? But let's get excited about what's going on. Knowing your software, knowing what's going on with your software, when we dove in it last time I was with you, we know that there's some people out there, and there's a reason why Starrag has partnered with you is because of the quality of your software, because we know the quality of Starrag as well. There's a deep reason behind this. When I think of some of the big machines and long cycle times that go into some of these parts, right? We say sometimes 12 hours, 20 hours, 5 hours, 30 hours. There's some big parts out there. Your software will actually break down tool per tool per tool and let you know if I have a 12-hour program and I could save time in X, Y, and Z areas, I can focus on one area that saves 11 out of 12 hours and the other one's 3 minutes, 2 minutes, 3 minutes, and then I can save time, and it's really focused on what's going on there. Now, I don't want to steal your thunder. You are way better at this than me. So let's talk about when the audience is watching right now and they go, okay, what are the real differences? Let's talk about those real differences, because we all want success. We all want profitability, and we all want to have what you exactly talked about just a minute ago with being successful across our company.
Yeah, absolutely. So I could show a few screens that are interesting, and like I said, high-level dashboards, just like everyone else, every other IoT platform you see out there. But what differentiates us is, it's about the tools, the programs, the process. We break down for engineers, an NC programmer working on this program. Hey, where is the biggest opportunity to improve? Which tools should I focus on? The process engineer, the machinist, the NC programmer, talk about this process. Try to get time out of the process, so you can see, hey, 25 tools ran in this program. The only reason to talk about it is to get time out of this area of the program. The rest of this doesn't matter. It's not going to gain you much. There's 3 tools in there that are problems, and there's a lot of potential improvement. So we could go from a high level to like a pretty granular level that's really actionable for like an engineer, and then we could get into the deepest level where you could see lines of G code and machine behavior as G code executes. So when we connect to a machine, we work with the the best out there with empty connect adapter solutions. We get everything we can out of the machine because most environments we're deployed in, they want everything. And then we're able to show machine behavior versus G-code. Some of the other things we're highlighting in the Starrag booth, we have both their LX21 and their Boomo connected today. But we also have a sensor technology we're working on with a company called MakerCorp, and patented technology out of Purdue University that's using propagated sound and neural networks. So we're kind of showing that off today.
Well, now that you've convinced everyone on the planet to give you guys a look, we got to let them know where to look, right? So what is that web address?
Yeah, it's tams.ai, TAMS.ai. You could find us there. If you're doing complex work, that should come talk to us for sure.
Absolutely, guys. And with that being said, we're going to send you over to Paul, and we're going to talk about some more fascinating technology with another partner.
What we're going to look at now is a brilliant illustration of the diversity of components and parts that the Starrag Group can manufacture. Now, I'm with Ricardo Berg. Ricardo, could you just tell us, company and your relationship with Starrag?
Well, we are a company Pocom, based in Germany, very close to the Drop and Rhine plant in Bielefeld. And there is a long relationship between us, more than 20 years developing production processes, tooling together, and just especially doing applications for customers where they have products like this landing gear, which is not a normal stuff you put on a milling machine, at least.
And this is what we're going to look at. I mean, look at this. I mean, this is absolutely... I mean, this is the type of parts, applications that you come to exhibitions to see, because you rarely see products like this. And what we're going to find out over the next few minutes is how this is made, what it's made from, all the machining processes. And if you're curious about anything, you've got any questions about this part or any other similar parts or any of the machines you've seen so far on this live stream, then please make sure you ask them now. We'll get them answered over the next few minutes. So, let's talk about this. What's it made for? Go on.
That's special steel. M300 they call it. It's a landing gear of 787, the Dreamliner, very comfortable. I like it to fly over to US. We have also other products like for the A380, 777 and Embraer and the other little planes. They are little different sizes, but this one is very unique. When I got in contact with that the first time, I was totally impressed. Today it's work as usual, I would say. We developed a couple of cutters for this production process together with the guys from Starrag and Drop and Rhine.
So how does it start? Forging. Explain.
Yeah, well, it comes from a company doing the forging. However they do it, that's not our job. We have an offset of that part, like 20, 30 minutes, depends a little bit when we put the material in on forging. And after that, we have a crust on there, which we need to remove to get all these features in there, like drill holes for any screws or for the cylindrical inside, which is with oil pressure, that you have this extension on there when the plane is going to land.
Okay, now I'm going to ask you about some of the... I mean, someone's just taken one of the tools out of there we were going to talk about, would you believe? But what I was going to find out is why the specialist tools. Why do you need them? Why can't you just buy tools out of a catalogue to do something like this?
Well, on this special application, it's not put it just on a machine and clamp it with a couple of screws. You need a special fixture. Everything of these parts need to be machined just for this one product.
So are you developing tooling for a product?
Yeah, we develop tooling if we have special applications like this. So this is a batten cutter, which a lot of people know in regular, but we put a special geometry on here. This is where the inserts are placed in the cutter, which coating we put on the carbide inserts, and so on. And this is all going together with the guys from Drop and Rhine from Starrag, where we can do testing on that, so that at least when the machine and the tool and everything is delivered to the customer, they can be sure that they have a product which is running, a complete production process.
Paul, we're not talking about the machine in masses of detail at the moment because we're really interested in the application and the tooling solution. What operations would this perform? Because I asked the question, maybe foolishly, how do you turn this? It's not turned, is it?
So no, it's just a complete milling application, nothing turning on here. The machine is turning the landing gear, the part itself, but on a special device, and we're not like on a lathe machine, at least. So we have all over we have this crust from forging. What we do with this cutter is we do the roughing, the first roughing, getting off as much material as possible in a short time, and then the cutter stays like it is, and the landing gear rotates with the turning table on there.
You know, some of the machines we've looked at today, very small medical parts, chasing extremely tight tolerances, right the way up to this from Starrag. What would be the tolerances and the surface finishes you need to achieve on something of this magnitude? Is that as important?
Well, you have on the most area of the surface, it's not so important. We would say 0.1, 0.2 millimeter is the tolerance, what we reach there. But when you have all this drill holes in here, where they put some axles through or anything else, there are tolerances you have to keep at that point. So they are doing that by boring tools or whatever.
Okay. And it's a partnership. I mean, these are some of the other tools, aren't they? Yeah. We won't go into detail about all of them, but so maybe...
We have the roughing tools, two different ones, because you have also smaller areas where you cut around. Just taking a big one, going into this corner will cause a lot of vibrations. So we just exchange to a smaller one, which has same diameter inserts and also the same geometry, specially made for them as an anti-vibration cutter at least. So there you can go much faster through the corners. You don't stop. Or we have special ones like a CBN coated insert, which the CBN, it's a special metal, which is weld on here, where we do the final finishing in areas like here in the front perhaps. We go around this area by a 5-axis milling, and the machine turns the right point where we go for making chips.
Okay, the big question, I'm sure you're all thinking it, but no one's asked it yet. How long does this take to manufacture? What was the supplier pushing you and Starrag, or the Starrag Group, to achieve in order to use your solution?
Well, when we start such a project, we try to calculate a little bit on the CAM system, how long it takes, and then you have the ways where you don't do any chips and you do the first cuttings. At least we were running at 26 hours of this 787 landing gear, and that was amazing. And now we are coming at the moment up to the next level. We increase the time about, I don't want to say too much, but like 25 to 30% down of the production time. That will be a big benefit for those companies doing that stuff. And I think it will clean up a little bit the market at that point.
So when I get on the plane home, one of these is probably made on a Starrag machine with your tooling.
Mostly of them are made on Starrag machines, and I feel absolutely safe. I'm always traveling a couple of times from Germany to US. I have no doubt about what this is doing. I know the tooling which was in there, and I know the machine doing that, so it's perfect matched.
What a great solution. Just shows you part of this live stream has been talking about the differences and the opportunities that Starrag Group offer on their machines to machine not just small, intricate, tight tolerance parts, but also industrial applications such as the ones we see here. Now I'm going to hand over to Tony, who's going to close off this live stream.
Thank you, Paul, for that wonderful explanation. We appreciate you. Now I am with my buddy Udo, and we're going to close this thing out with some real educational pieces that I was privileged to learn the other night at that wonderful dinner. Thank you so much for having us. But now let's share that information with the audience, because the growth, the expansion, not just here at IMTS or in Kentucky, but down into Mexico, which I think we talked about with Fur as well. You have so much to be proud of that's going on here, Udo. So congratulations, but let's talk about that with the global audience watching right now.
Absolutely. So of course this week we will spend our time here at the IMTS, but right on Saturday we will pack our machines, bring them back to our headquarters in Hebron, Kentucky, where we just finished a big extension of our showroom. So we are planning to bring more machines in. We poured foundations for the big machines to demonstrate them in real production environment. And I'm flying down to Mexico, and we look for buildings to open our Starrag Mexico facility, where we also will provide sales and service and later in the year application support for our customers down in Mexico.
So I want to take a couple of those pieces and emphasize them with you as well, because I know they're important to you and I want the audience to understand what we're talking about. The expansion in Kentucky. A, first of all, you are very near the airport, so easy to visit. B, there's so much beauty around there. There's reasons to visit, but the important part to me in the expansion is inventory that you are having there. How important is it to be able to support your customers here in North America by increasing your inventory so that they can get parts overnighted or even same day?
Tony, that is absolutely important. I mean, the machines which we are selling, and we call ourselves a solution provider, it is absolutely important that we provide an absolutely excellent service, and service includes spare parts. And right in Kentucky, we have a facility for spare parts. Our inventory is currently 1.5 million US dollar, and with every machine coming in, we check our inventory, we check the bill of material. If needed, we add parts to it. So we have a parts guarantee 24 hours.
That's a pretty good guarantee. Now, just to reiterate the Mexico thing, you're going down to Querétaro. How excited are you about going to that area? And I know you already have machines down there in Mexico, which is what inspired bringing a building down there to make sure that they're supported.
Absolutely. We have, since years, we have a solid install base down in Mexico, and certainly automotive and aerospace, which really falls into our wheelhouse, is a growing market down in Mexico. And we must be closer to, or we would like to be closer to these customers, and therefore it is very important that we have local people based in Querétaro.
So I don't know the answer to this question. Have you been to Querétaro? Do you love Querétaro? I've been there many times. It's one of my favorite cities in Mexico. And are you a taco fan?
Absolutely. And I like Querétaro. You are absolutely correct. Yeah, I have been there several times, seeing our customers down there, and certainly look for the building and do all this kind of stuff. I like it.
Muy bien, excelente. So one more question I have before we get off of here is just to offer you the opportunity. Are there any final statements, almost like that crazy Jerry Springer show that used to be on at that final statement? Is there anything we didn't ask you today that you would like to talk about with the audience as a last minute message?
Absolutely. I mean, I told you earlier that we will bring the machine back to Kentucky in our fresh new showroom, and we are very excited to plan for our grand opening in Q1. And I hope I see all you guys in Q1 in wonderful Kentucky, and we maybe have a bourbon together.
I think we should have another bourbon together as we do that. Udo, thank you so much for your time. Thank you all for watching. This is IMTS 2022. This is the Starrag booth. Come take a look. 7-axis machines, large machines, small components. You see it all here. Come say hi to the folks at TAMS. Incredible technology. One last time, thank you all for watching. Udo, you're amazing, my friend.
Have a good one.
They're just going to make